Introduction to memory management in C and C++. What is a memory management? Memory management in C++ gives a high level of control to developer over how memory is allocated and deallocated. In essence, it's all about allocating and freeing memory space during the execution of a program. To utilize its full power, it's essential for a developer to properly understand memory management in C++. Why memory management is important? In C++, memory management is crucial for many reasons, like efficient use of memory resources. With proper memory management, we can utilize the system resources in a better way. It will also increase the overall performance of application. For instance, if memory is poorly managed, an application may consume more memory than necessary, which could lead into a slower system performance of application or even cause the application to crash when the system runs out of memory. Second point is prevention of memory leaks. Memory leak occurs when a program allocates the memory on the heap, either by using the new operator or malloc or calloc operator from old C style functions, but fails to deallocate it. A memory leak can cause the application to slow down or even cause the application to crash. Efficient memory management is necessary to avoid the memory leaks. Speed of allocation. Memory management from heap, that is dynamic memory allocation, is usually much slower than memory allocation from the stack. Performance of application can be improved by minimizing dynamic allocations or by using custom memory allocators. Next point is fragmentation. Fragmentation occurs when memory is allocated and deallocated frequently, and the whole heap area gets broken into many small non-contiguous free blocks. This can make it impossible to allocate larger blocks of memory. This can slow down the application. To minimize the fragmentation, good memory management techniques can be used. Next point is concurrency and multithreading. Good memory management techniques can help in managing shared memory resources in multi-threaded environment. And the last point is security. Memory management can cause serious security implications. For instance, if memory is not managed properly, it may leave data residues which can be exploited by malicious entities. In conclusion, by efficient utilizing memory management techniques, we can build efficient, responsive, and robust applications. Memory management in C and C++. In C and C++, memory is divided into two main parts, stack and heap. Stack is used for static memory allocation and the heap is used for dynamic memory allocation. Memory management in STEEP is responsibility of a programmer who should consciously allocate memory whenever it's needed and deallocate it when it's not needed. This differs from languages to languages. Like in Java, garbage collection is performed automatically. While this may seem like an extra burden for a C or C++ developer, it also gives programmer a level of control over the program's efficiency and resource usage. This controls allows C and C++ programs to run faster and use memory more efficiently than programs written in other languages that handle memory management automatically. Memory management is an extensive subject, involve various functions like new, delete, malloc and calloc, and free. In the following section, we will explore these concepts in detail and provide a comprehensive understanding of memory management in C++. Memory management is one of the critical aspects of programming in C++. While it does demand more attention from the programmer compared to other languages where automatic garbage collection is done, but it also provides a level of control and efficiency that can be crucial for performance critical applications. By understanding the basic principle and methods of memory management in C++, developer can write safer, faster and more efficient programs. That's all for this video. In the upcoming videos, we will discuss more about the functions that we can use for memory management in C++. This video is a part of Pointer's course in C and C++. For more videos related to this course, you can check out our playlist on YouTube or you can go to our website thispointer.com for the complete course. Thanks for watching. Don't forget to like the video and subscribe to our channel.